Okay, so today we're going to be in a new section. It's going to be 12-1, and we're going to examine quadratic functions. And we're going to focus a lot on graphing today. So you guys are going to be able to understand the elements to a quadratic function, and then you're going to graph a quadratic function using transformations. So a quadratic function is a function of this form, f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, and a cannot equal 0 because imagine if a was 0, well, that's just a linear equation. So that's why a actually has to be a real number. Now we already know that most of the basic quadratic equation is going to be y equals x squared, and that's the example of it here. And we call this the parent graph. Now we've already talked about these transformations, we already talked about these parent graphs, but we're going to kind of see this all cycle back through again. Now the point 0, 0 is called the vertex, and it also represents that relative minima in this sense. So it's the smallest, the lowest possible value on the graph. So let's go through and graph them. So it says graph and find the following. We know that y equals x squared using transformations. Then find and label the vertex, the x and y intercepts, and the domain and range. So I know based upon this, I know it's going to be parabola. There's going to be a shift over 2, and it's going to go down 3 based upon those transformations. So my vertex that normally starts here is going to shift over 2 spaces, and it's going to move down 3. So that's going to be the new value of where my vertex is going to be. So now I just need to pick values. So here's my table. So if I pick like -3, -4, you're going to see how they're going to match up for -1 and 0. So if I plug in -4, sorry, -3, I'll switch these. It'll make them easier. So if I plug in -3, I get -1 squared. -1 squared is 1. 1 minus 3 is -2. Well, that's going to be the same value here. So these are going to be -2. And then if I plug in 0, I get 2 squared, which is 4. 4 minus 3 is 1. So these are both going to be 1. And so this will be 1. And this will be 1. And so my parabola is going to look like this. So having said that, find and label the vertex. Well, my vertex is going to be -2 and -3 because that's where it shifted. And then it says the x and y intercepts. So if I wanted to find my x and y intercepts, if I wanted to see where it crosses the x-axis, that means I have to plug in 0 for y, so 0 equals x plus 2 squared minus 3. So now solving for x, I'm going to add 3 to both sides. So 3 equals x plus 2 squared, square root both sides, minus 2 on both sides. I get x equals -2 plus or minus √3. So those are going to be my zeros, and then writing them in terms of my x-intercepts, I'm going to have -2 plus √3, 0, and -2 minus √3, 0. And my y-intercept, okay, where does that cross the y-axis? Well, we can see that it crosses here, or if I just plug in 0 in for x, and if I plug in 0 for x, I get this value here. And my domain and range, so my domain is going to be -infinity to +infinity, like all polynomials, and I just said it was in the previous slide. And my range, we know it starts here at -3, and it's going to go all the way up to +infinity. If I wanted to find my minimum, my min is going to be -3. Next example here. So for this one, looking at my transformation, it's going to move over 3 and it's going to move up 1. So it's going to move over 3 and it's going to move up 1. Now that I have that value here, I can create my chart, plug in some values. I know that at 3 it was 1, so if I pick 2 and 1 and 4 and 5, so if I plug in, let's say 4, 4 minus 3 is 1. 1 squared is going to be 1. 1 times negative 2 is negative 2. Negative 2 plus 1 is negative 1. So these are both going to be negative 1. Now if I plug in positive 1, 1 minus 3 is negative 2. Negative 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 plus 1 gives me negative 7. So these are going to be negative 7. So notice my parabola is going to be, looks a little narrow. That's the reason, is because we have a vertical stretch. And then also goes upside down because we have a reflection. So you see how it all comes back together. So now finding and labeling all that information, my vertex, that's going to be 3, 1. My x-intercept, it's where y is 0, so I'm going to say 0 equals negative 2 times x minus 3 squared plus 1. So minus 1 on both sides. Divide both sides by negative 2. So then if I take the square root, this rationalizes into root 2 over 2. That's plus or minus. So add 3 to both sides. So I'm going to get x equals 3 plus or minus root 2 over 2. And so my x-intercepts, I'm going to say, are 3 plus root 2 over 2, 0, and 3 minus root 2 over 2, 0. Now my y-intercept, I plug in 0 in for x. So if I plug in 0 in for x, I get negative 3 squared. So I can say 2 times negative 3 squared plus 1, so that's 9 times negative 2. It's negative 18 plus 1, so that's negative 17. So it's going to be 0, negative 17. And then the domain, once again, is negative infinity to positive infinity. The range, that's going to be now negative infinity to positive 1. So if I were to project it, okay, it's going to go all the way up till I get to that 1. And then my, let's say if I wanted to find the absolute max or min, my absolute max or min, that would be a maximum, because that's the highest possible value of 1. So instead of focusing all that time on finding all the little pieces of information for here, what we're going to do is we're just going to focus on finding the, just kind of graphing it. So just know that it's going to shift over 6 into the negative direction. It's going to move down 1. So 1, 2, 3, 4, 5, 6, and move down 1. And so if you plug in values, it'll look something like this. And because of this, there's a reflection over that x-axis, and that's why my parabola is facing down. Now, there's actually going to be 2 forms to every quadratic equation. There's going to be this general form, which is ax squared plus bx plus c. And then what we have just worked with when it came with those transformations is called the standard form. Now, the vertex of the standard form, without even having to graph it and take a look at what that vertex is, you can look at the equation and understand what my vertex is once it's in that standard form, because we're going to define the vertex as being hk. So if my vertex is going to be hk, we should be able to do that. So let's look at an example to be able to determine what my vertex is. So if I have x plus 2 squared minus 3, well, graphing that with the transformation, that moves over negative 2, and that's going to be down 3. So 1, 2, down 3. And so that's going to be here. And then so my graph will look something like this. And then just looking at this, my vertex is going to be negative 2, negative 3. But looking at this here, well, my h if it's saying that my equation is x minus h squared plus k, well then my h says do the opposite here. So doing the opposite, my h is going to be negative 2. My k, do the same because it says plus k, is going to be negative 3. And so my vertex is actually going to be negative 2, negative 3, just by being able to look at my standard form equation there. Now another thing to point out, the equation x equals h is always going to be the axis of symmetry. And so if you notice, if I draw this imaginary line down, now granted I didn't draw my parabola beautiful enough, but this right here is the axis of symmetry, and it's always the equation x equals h. So notice it's the equation x equals negative 2 in this case, a vertical line that goes straight up and down at negative 2. Now the reason why they call that the axis of symmetry is that's the value in which my graph is perfectly symmetric, which means folded of each other perfectly. And then here it says k always represents the relative max or min, and so right here, if I look at my k value, negative 3, well, that's the smallest possible value in my graph, so I have a minimum of negative 3. So this concludes our lesson. If you guys have any other questions, please leave them in the comments.